Hello everyone. So you see some pictures on the board? Yes. So it's a recap time. So can you look at this? Do you remember where did we use it? And what is the name of this particular instrument? Same way, what is this? As you can see, it's already showing voltage. And what is it? Okay. So this is an instrument which measures current. So it's the ammeter, right? This is an electronic voltmeter which calculates, measures voltage. So voltmeter, sorry. And the other one, if you remember in the previous video, we actually learned about it in more detail, and that was the resistance, right? Okay, can you tell me who was the person who derived the relationship between these three: current, voltage, and resistance? Yes, it's Ohm's law, or the scientist named as Ohm, who had done many experiments. And in one of the experiments, he explained that voltage is directly proportional to current, and we got this relationship: voltage is equals to current times resistance. We can change this formula as voltage upon current will give me a resistance, right? Same way, voltage upon resistance will give me a current. So these are the three formulas which we derive from Ohm's law. So this was just a short recap from previous video of what we had already learned about. Okay, so we'll move ahead a little bit more, right? Okay, so now in a normal day-to-day life, there are many different types of connections of lights or electrical gadgets that will be coming across. Okay, so we know that the current through a conductor depends upon the resistance, first thing, and the potential difference across its end. So various electrical gadgets often use resistors of various combinations. We will find out how Ohm's law is applied in these combination of resistors. The two major methods of combining resistors is series connection and parallel connection. In this video, we'll focus only on series connection, and in the next video, I'll be explaining about the parallel connection. Okay, before we go into the physical terms and the physics-based explanation of series connection, I want to quickly show you something. Okay, have you ever seen these lights? What are these called as? Fairy bulbs or serial bulbs, which we use it in? Which one? Yes, during Diwali or Christmas or marriages, we decorate our hall or rooms with these serial bulbs. These are all the same fairy bulbs. Okay, what do you clearly see here is one bulb is directly connected to the other, the next bulb is connected to the third one. So are these bulbs connected one after the other? And there is a common wiring which is connecting all the bulbs one after the other. This is called as series connection. Okay, now if you want to look at series connection, so can you clearly see here the switchboard? Okay, the first wire is connected with the bulb. The bulb is further connected to the neutral, that is the main board of our house. From there, the second wire which comes out of the board is connected to which one? Yes, my switch, the on-off switch, right? The on-off switch, second wire is connected to the plug. So is there a continuation of connection? There is no crossover. So this type of a connection is called a series connection. Correct? Where one after the other is connected with a continuation. Right? So we'll just look into a very quick activity by using the virtual lab and see how different resistors are connected in the series connection and how does that change either the current or voltage. That you have to see and find out which one is changing. Is it the voltage which is changing or is it the current? Okay. So now I'll be taking two batteries, okay, and I'll be taking three resistors which I'm putting one after the other. Can you see here? Okay, let me place it a little bit above because I want to keep my voltmeter also. Okay, I'm going to connect this. Let me put my ammeter somewhere here, right? And my switch. Let's put it somewhere here, right? So now the only thing we need to connect is the wires. Okay, sorry. Okay, let's connect them all with wires. And then we put the switch on. But before we put the switch on, we need to make sure are the resistors, the values of the resistors. Okay, and we'll set it. How? I'll show you. just put it at the back. Okay, let us take it up. Yeah. And then so let's check what is the voltage of my battery and the resistors. Okay, so let's see. So can you see here the voltage is shown as 9 volt and the other battery is also 9 volt. So the current that is going to, so the voltage of the battery will be 9. Let's check my resistors. All the three are 10 ohms. Okay, so let's first check what happens with the current and the voltage. So let me put my voltmeter here, somewhere here. Okay. Okay, I've not changed the resistance of all the three resistors. They are of the same equal measurement. So let's see what happens. Okay, let's connect it. Can you see the current is flowing very slowly and the ammeter reading is 0.60. Let's place the voltmeter. Okay, between the first and the last resistor. It's 18 volts, right? Let me bring it to the second resistor. So it's between this point to this point. What is the voltmeter reading? 12 voltmeter. The current is still 0.60. Let's watch. If I'm keeping it here, it says 0.6, sorry, no change. If I'm bringing my voltmeter reading till between these two resistors, it's changing to 12 volt. If I changing to this, 6 volt. Okay, so the voltage is changing. Let's do one change. Let me just open the screen. I'm going to change the value of the resistors. So let's change this to a 5 ohm. Okay, let's change this to a 7 ohm. And let's keep the other one as 10 ohms. We are not changing that. Okay, let's see the amount of current flowing and the blue balls. Are they going faster or not? And just check what is the value of the current and then the voltage. Okay, and then I'll bring it between the two resistors. So now the current is how much? 0.82, right? The voltage is again 18 volt, 9.682. So if I see here, the voltage between these 2 points is 4.09 between this resistor. If I'm bringing it to this resistor, the voltage has changed to 5.73. And this one, if I change it between these this two, it's 8.18. So this was my 5 volt, 5 ohm. This was 7 ohm and this was 10 ohm. So can you see the voltage changing across 10 ohm resistance? The voltage is 8.18 and current is same 0.82. Across my 7 ohm resistance, the voltage is 5.73. The current is same 0.82. Whereas across the 5 ohm resistor, what is happening? The voltage is changing to 4.09. The current is same. So is the current remaining the same? Yes. But what is distributed between the resistance? It is the ohm. That is the voltage which is getting distributed. Clear? Yes? Okay. Okay, so we just saw the I'm sorry for the interruption. We just saw the electrical connection in series, how the resistors was connected one after the other. We also saw the change in voltage between the resistors. So the same thing I've taken here. Okay. 5 ohms, 7 ohms. This time I have taken 5 ohms, 7 ohms and 8 ohms. So the current is 1.80. So the current was same. Remember, against the resistors, it was different. I've just done a little bit change. Instead of the resistors, I've taken my bulbs. Right? So it was again changing. For different bulbs, I'm using different ohms. Okay, resistance I've changed in this case. And my current was same for each bulb, 1.05. But the brightness of the bulb, can you see it is different? That means this bulb was having more resistance. That was around 10 ohms. This was having around 7 ohms. And this was having around 5 ohms. So the brightness is different. Can you make it out? Correct? So what is changing in a series connection? Voltage changes. And what remains same? The current. Okay? So this is the basic structure of electric circuit we saw in the virtual lab. If we are supposed to draw it, this is how we'll draw it. The first resistor connected to the second resistor, connected to the third resistor. The battery, ammeter and voltmeter is across all the three resistors. If I want across only R1, then I'll put across R1. If I want to put across R2, then I'll put across R2. And the key is closed. So for the battery, we are taking the voltage as capital V. The current flowing is capital I. Okay. So across R1 ohm resistor, the voltage we'll take as V1. Across R2 resistor, we'll take the voltage as V2, and across R3 resistor, we'll take the voltage as V3. Okay, so this is what I have written here. Voltage for the battery is V, amount of current is I. For resistor R1, current remains the same as I, voltage is V1. For R2 resistor, current is I again, voltage is V2. For resistor 3, R is R3, current is same I and voltage is V3. The potential difference, that is the voltage, is equal to the sum of all the three different voltage that we get across R1, R2 and R3. So total potential difference across a combination of resistors in series is equal to what? The sum of individual potential differences which we are adding up. So V equals to V1 plus V2 plus V3. Okay, first we'll be applying Ohm's law for individual case. So let's say for battery. What we are getting? Total voltage is equals to current times resistance. For resistor 1, okay, what we'll get? V1, okay, for resistor 1, we'll get V1 is equals to IR1. Why I'm writing I? Because there is no change in the current. Then resistor 2, V2 equals to what? IR2. And resistor 3. Upon resistor 3, it's V3 equals to IR3. If you observe, I have not changed the value of current because it was same. Now, total voltage, total potential difference, not voltage, the potential difference of the total circuit will be equals to addition of individual potential difference across the individual resistors. I'm sorry, this is V2, V3. Okay, so this is across R1, R2, R3. So I have to add the voltage difference, potential difference between individual resistors. So V, according to this Ohm's law, I have written IR. This will be IR1. This will be IR2. And this will be IR3. Can we say I have I as a common? So I'll take that as common. So IR is equals to I, common bracket. So R1 plus R2 plus R3. I have I on both the sides, so it's cancelled off. So resistance is equals to R1 plus R2 plus R3. So here the resistance R is said to be the resultant resistance of the circuit, which we will get by just adding the resistance of the individuals. So if I am saying that, if I quickly take that, the first resistance that we took was, if you remember, 5 ohms. The second was 7 ohms and the third was 10 ohms. So if you add, the total will be 22 ohms for my total circuit. Okay. Am I clear? So can we just quickly check that whether we are getting that or not? Let's quickly check. This is 5 ohms, 7 ohms, 10 ohms, right? So let's put the key and I'm going to check what is my voltage, 18 voltage, right? The total resistance will be R1 plus R2 plus R3 and voltage is 18, 0.82 is the current, correct? So you just need to add it, right? So can you do 18 and 0.82? One thing that we can do is cross check whether we are getting this formula right or not. We can say the voltage that we got in our experiment was 8 volts and the current that we got was 0.82. By Ohm's law, V equals to IR. That means V upon I equals to R, right? That means I can say what? 18 divided by 0.2 will give me a R. And that is approximately 21.8 equals to R, means 22, right? So for the whole circuit, if I'm applying the experimental value of voltage as 18 volt and current as 0.82 ampere and I'm applying it in the formula of Ohm's law, I'm getting 21.8. And when I'm doing the series formula by adding the individual resistance of resistors connected in the series connection in the electric circuit, when I'm adding those resistors, the total is also coming out to be 22. So the resultant resistors of the resistance of the series connection is equal to sum of potential difference of individual resistance. Hope this is clear. Thank you.